Hello everyone, here is a question based on ozonolysis. We have 4 different isomers of C10H14 that are given in list 1 and then their ozonolysis products are given in list 2. We need to match these two and find out the correct option here. The key point that you need to keep it in mind in this question is, if the double bond has hydrogen, then you are going to get aldehyde there. So, for example, this double bond has hydrogen here, hydrogen here. That means that when it forms ozonide and then you get the product, you are going to get aldehyde here, aldehyde here. On the other hand, you are going to get ketone here because this has no hydrogens. It is connected to carbon on both sides, isn't it? So, therefore, ketone here, aldehyde here, aldehyde here. So, your product should have 2 aldehydes and 2 ketones. So, see on the product side which one has 2 aldehydes and 2 ketones. And the other important thing is, aldehyde is a terminal functional group. So, this will always come at the end. This hydrogen is not shown here, this is not a ketone, this is a aldehyde. We have a hydrogen here, we do have a hydrogen here, we do have a hydrogen here. So, we have 2 aldehydes here, 2 ketone here. In product 3 also we see 2 aldehydes and 2 ketones. So, therefore, the dissociative product here should either be should either match with 1 or it should match with 3. It cannot match with 2 and 4. Why? Because in 2 and 4 we see only 1 aldehyde. We see 1 aldehyde here, we see 1 aldehyde here and 3 ketones, and therefore, A should match with either 1 or with 3. So, let us write the ozonide and then we will figure out which is the correct product here. So, we have a bicyclic compound here. So, that is our bicyclic compound. If this reacts with 2 moles of O3, then we will get the ozonide, and the ozonide or diozonide, let us say, and the diozonide structure will be like this. And then here also we have O here, CH2 and then CH3 here, and then here we have the carbon here, and this one, this carbon, we have oxygen here, and then this carbon is attached to this carbon here. We have a carbon here. So, O here, and then this is CH2, this is connected here. So, now when we put zinc and water, the dissociation happens this way. We can break this, we can break like this. So, now the product will be, start from here, we are going to get aldehyde here, we also going to get aldehyde here. So, start from here. So, if we start from there, then this is our aldehyde. So, let us write it this way, and then CH2, CH2, one CH2, another CH2, and then ketone. We have a ketone here, and then CH2 again, and then CH3, and then CH2, and then ketone here, and then this ketone is connected to an aldehyde. We should have 9 carbon atoms on the chain. Do we have 9 carbon atoms? Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9 on the chain, and then 1 methyl group. So, total 10 carbon atoms we have. So, therefore, this product is matching with which one? Now, this is matching with 3, isn't it? The structure of 3 is what we wrote. The structure whatever we wrote is actually mentioned in 3. So, therefore, A should match with 3 and then now we will figure out B is matching with which one. Then we can find out the correct option. So if A is matching with 3, then this is wrong, this is also wrong. So if we find out one more product, then we can find out the correct option here. So let's work on B. So we have the structure of B here, and that is so we are going to get aldehyde here. That's the only place you will get aldehyde. So it reacts with 2 moles of O3, let's say, and then the ozonide structure will be like this. So we have O here, and then O, this is connected this way, and then here another O, and then this carbon is connected this way. We have a methyl group here, and then we have CH2, and this is connected here. Okay. So this is CH3. Now if this undergoes reductive ozonolysis, so then the breakup happens this way, then here too like this. So start from where you will get the aldehyde. Here we will get the aldehyde, isn't it? So start from aldehyde because that is our terminal functional group. So we write the aldehyde first, and then this aldehyde is directly connected to this carbon. So that is there you will get the ketone, and then 1, 2, 3, 4 CH2, 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 CH2. Okay. So we are starting from here, that is where we will get the aldehyde, and then ketone here, and then CH2, 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 CH2. That's what we wrote here, 1, 2, 3, 4, and then you are getting a ketone again, that is there, and then CH2 here, and then another ketone, but that ketone has a methyl substituent. So now this one should have 10 carbon atoms on the chain. So let's check it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We do have it. So it is matching with which one? That is the question now. So whatever the product that we wrote is matching with which one? It is actually matching with the 4, isn't it? We have the aldehyde here, we have the ketone here. It just written like flipped version of it. Aldehyde, ketone, and then 4 CH2s. Aldehyde, ketone, 4 CH2s, 1, 2, 3, 4, and then ketone again, and then CH2, and then ketone again, and then CH3. That's what we have here. So basically if this compound undergoes ozonolysis, we will get 4. So B is matching with the 4, and this means that we already figured out that these two answers are wrong, and A is matching with the 3, B is matching with the 4. Therefore 2 is the correct option here. You can work out for the remaining 2 things yourself. Okay, that would be an exercise. Here we have a hydrogen atom, then you will get a aldehyde. That's the key point that you should keep it in mind.